Hi there, Mr. Lees here, doing the higher paper from 2021, paper 2, and we're on question 5. We have to express 3 cos t plus 5 sin t in the form k sin t plus a in degrees, where k is greater than 0 and a lies between 0 and 360. So we can now just go on with that one there. And I'll just move this to this side here, and here we go there. So there's what we have to do, express that in that form there. So what you do is you look at your formula sheet for the sine of a plus b, and we adapt it. So the sine of t plus a is sine t cos a plus cos t sine a. So multiply through by k and swap these round. We have k cos a sine t plus k sine a cos t. There we have it there. So we multiply both of these by k, but swap them round. There we have it there. This allows you to compare. So we have sine t and k cos a, sine t and 5. So k cos a has to be worth 5. And over here we have cos t and k sine a, cos t and 3. So k sine a has to be 3. So k cos a is 5 and k sine a is 3. So hopefully you realise that k squared is going to be 5 squared plus 3 squared. Again, just use your calculator. Gives you 34. K squared is 34. So k is the root of 34, which can't be simplified. So we have, substituting k for root 34, there and there, we have root 34 cos a is 5 and root 34 sine a is 3. So just moving the root 34 down below the 5 and the 3, we have cos a is 5 over root 34 and sine a is 3 over root 34. Now cos a and sine a are both positive, so a must lie in the first quadrant. That means it lies between 0 and 90. So I just did a shift cos of 5 over root 34, and you get 30.96. So just to summarise your final answer, 3 cos t plus 5 sin t is root 34 sin t plus 30.96. And just having a quick look at part B. So a function f is defined by the one we've just been working with for t between 0 and 360. State the minimum value of f of t and determine the value of where that occurs. So here we have it there. So there's your function there, and of course part A would invite us to replace it with this there. So part A was all about changing that to that. This allows you to get the minimum value, because the minimum value of this function here occurs when the sine of t plus 30.96, when that is equal to minus 1. The lowest sine anything ever goes to is minus 1. So we have 34 times minus 1. That gives you minus, I should say, root 34 times minus 1 gives you minus root 34. And part 2 was determine the value where this actually occurs. So, as I said earlier on, this minimum occurs when the sine of t plus 30.96 is equal to minus 1. So let's set that equal to minus 1. Now, if you remember your sine curve, you should know that the sine of 270 is minus 1. So t plus 30.96 has to be 270. Move that over and change the sign. So t ends up being 239.04. And that's your final answer.